Now, here's another example of different types of problems. Is we have, in the next set of problems, we're going to be given a function, and we want to find its inverse if we can. We also want to find its domain and its range if we can. So, first of all, we have a function on this first one in A, which is y equals 4x minus 5, and we want to find its inverse. How do you find something's inverse? Well, remember the idea behind inverses is swapping x's and y's. So that's all we're going to do. We're not going to do anything different. We're going to find the inverse by swapping x's and y's. Okay, so that means that this equation, wherever I had a y, I'm going to put an x, and wherever I had an x, I'm going to put a y. So what it'll look like now is x equals 4y minus 5. So far, so good. However, whenever we have functions, we have them equal to y. Now it's equal to x. So I just need to do a little bit of algebra and solve this guy for y. Well, how do you solve this guy for y? Well, we'd start off by adding 5 to both sides, which will give me, let's see, an x plus 5 equals 4y, and we moved the 5 to the other side, so that's gone. Last step to get the y by itself would be to divide both sides by 4. So what that gives me now is, let's see, y equals x plus 5 over 4, or you can write that as y equals 1/4 x plus 5/4, because remember, it's the same thing as saying there's a hidden 1 out in front of the x, and that would give me a 1/4 and a 5/4. Now, here's the problem. It's going to be very easy to get confused about which function's the original and which one's the inverse, because now they're both called y. So people got really frustrated with that, so we're going to change the notation. We're going to call the first one the f function, and then we'll call the one that was our inverse the f with the little -1, f inverse, so that we don't get confused. So our inverse is the 1/4 x plus 5/4. Our original function was the 4x minus 5, and let's make sure that we remember that it should be f of x, and the inverse should be having the x2. Now, the next thing that they wanted us to find was the domain and the range of both the original function and the inverse. Well, let's take a look at the original function first. Well, the original function, y equals 4x minus 5, is just it's a line. It's in slope-intercept form. The y equals mx plus b. So it's looking like, and it's got a positive slope, something like this, a line going up forever. What do we know about the domain of a line? Well, they go left and right forever, so its domain is going to be -infinity to +infinity. What do we know about a line's range? Is it's also going to be -infinity to +infinity, because they go up and down forever. Now, let's take a look at our inverse down here at the bottom of the page. Our inverse is also a line. It's also got a positive slope, so it's going to be going up and down and left and right forever. So it's also going to have a domain and range of -infinity to +infinity. However, I'm going to point this out. Even if you didn't know that this second graph, the inverse, was a line, you could still figure out the domain and range. Here's the awesome part about inverses, is whatever the domain of the original function is, remember, the inverse is swapping x's and y's. It should become, domain as x's, it should become the y values, the range of the inverse. So even if I didn't know what it looked like, I should just automatically copy, then domain will become the range of the inverses, swapping the x's and the y's. which also means that the range of the original function, the y values, would become what in the inverse? It'd become the domain, which is the x's, because you'd be swapping x's and y's. So if you didn't know what the inverse even looked like, you should be able to just copy that the domain becomes the range of the inverse, and the range becomes the domain of the inverse because you're swapping your x's and your y's. It's pretty neat that you can do that. In this next problem, we're going to look at the problem negative x squared plus 2. There is a small issue with this function. Remember that with the x squared graph, we have a parabola shape because of the squared. So what that means is we're looking at a U shape. However, because of the negative sign out in front, it's actually going to be doing the reverse. It'll be pointing downward. And then the plus 2 as well will be shifted upward. So we've got a parabola that's been shifted up 2, but that's pointing downward from that 2. So it'll look something like the following. So because of this, what we notice is that if we look at the horizontal line test, it's going to fail because you'll have this graph being hit by a horizontal line more than once. So it's going to fail the horizontal line test, which means, remember, if it fails the horizontal line test, it means it's not 1, 2, 1. Which also means it does not have an inverse. Because the inverse then would not be a function. So, however, they still want us to find the domain. Well, remember, looking at the domain means to read the graph from left to right. And notice on this graph, from left to right, it actually goes from negative infinity to infinity. It doesn't start or stop. It goes on forever in both directions. It goes all the way from negative infinity to positive infinity. However, looking at the range along the y-axis working from negative infinity to positive infinity, what we know is it does start out with a negative infinity and works its way up all the way up to the top here at the value where we shifted it up to. And again, we do have a point or a graph there, so we're going to use a bracket at the 2. So we can still give the domain and range because it's a function. However, it will not have an inverse. Let's take a look at the next one and see.